Hello friends, welcome to my YouTube channel Solidworks Tips and Tricks. I hope you are getting much confident in simulation day by day. So in this session we are moving forward to our next lesson, that is lesson number 6, compatible incompatible machine of our static simulation series. So let's start with this exercise. Basically, we have one rotor with the blades, so we have to do simple static analysis by applying a centrifugal force, which is a global force. We need to just check what is this compatible and incompatible machine will affect our results, and how to use, means where to use which machine. So today's topics are compatible solid element mesh with the bounded contact. Basically, these are the three analysis means study we are going to create. First one is a compatible solid element mesh with the bounded contact. Second one is an incompatible solid element mesh with the bounded contact, and third one is a simplified bonding mesh for incompatible solid mesh. So we will see each one of them. So we will start with our first compatible solid machine. For that I need to open the model. So here I have this model with the alloy steel as a material. So basically my boundary conditions are this face is a fix, and as a centrifugal force I am applying here, which is a global one, means basically we have gravity and centrifugal are the global forces. So for a centrifugal force you need to select one axis. So I have created here, I'll just show it. Okay. So we will create a new study, and here I will give name compatible mesh. So we'll start with it. So as I have given a material, it will come automatically in your study. As you can see here in model, the whole model is not a single part. I have created it with as a multi-body, means this basically below router is our main part and other one are the blades. So here you can see there's a different bodies. Okay, now on connection, because of multi-body, whenever there is a touching face, there should be a bonded one, and actually here we are going to do a bonded contact. For that you can see here bonded is automatically defined. Now for fixture I will select fixed geometry. In that I will select the bottom face, and okay. Now for external load I will go for a centrifugal one. Here my value is 1 radian per second as an angular velocity, and here you can select h for reference, centrifugal reference, h axis, cylindrical face for direction. So I will select, let's say, this axis. You will get the direction of your centrifugal force. Okay, so this is my centrifugal force. Now before applying mesh, I will change my contact condition. Means I will show you where that compatible, and here you can see the option compatible mesh and incompatible mesh. Basically by default it's a compatible mesh. We are not going for incompatible mesh. So with the help of this compatible mesh we are see what are our mesh conditions. So for that I will go for apply mesh control, and I will select these four bodies. For apply mesh control, basically, okay, so here I will select 2.3 mm. Okay, and okay, so for now creating a mesh and apply. So by default whatever values are there, and I will go for a okay. So its meshing is coming. Okay. Because of apply mesh control we can see the blades are with the finer mesh, and our basic blade with the road is coarse mesh. Not too much coarse, but not that much of fine. So because of this compatible machine, you can see here the nodes are matching, means the blade and below plates nodes are matched with each other. If you want to, if I go into the model and if I select one blade and again I will go for our simulation study. And if you see here, so as my blade is hidden, you can see the structure or imprint of my blade here with the same nodes, means at the bottom of blade, how the mesh nodes are there, similarly made nodes are imprinted here. So the my transition or calculation is much easier in this case, and all conditions are uh, considered. So if I go here, if I see, sure, okay, okay. So basically, in this case, you can see this is my source. Means if you go for a show mesh, this is my source elements, and these below are my target elements. So load is transfer means the calculation is happening between this node and other node. And due to compatibility, the nodes are matching with each other. And as the bodies are separate, each one has each nodes separately. So if I go for a run this study, the study will run. Okay, because of singularity means here sharp edges are there, so you will see some unrealistic value for those. Okay. So here you can, if you see displacement, my displacement value is 4.2 into minus 7. Okay, now we will do same study with the incompatible mesh, but in incompatible we have two options. One is a accurate one and one is a simplified. So let's see, we will start with this. We will copy this study and we will give study name as a incompatible. Accurate mesh. Okay. Okay. Now in this, I just change my component contact from compatible to incompatible one. Okay. And for property, you can see incompatible boundary condition is automatic. I will go for a more accurate one. So okay, I will explain what that exactly means. Okay, so I have changed my incompatible meshing condition and also have contact condition. So I will go for a run, so it automatically mesh with the help of incompatible and then run. Now I will go for mesh first. Mesh. So show mesh. Yeah. Here you can see the changes. Where where I have applied apply mesh control, the blades are with the final mesh and bottom blades is with the post mesh. But if you see here, the element is node to node contact are not that much simplified or not that much implemented. Means if you go for a model, and if let's say I had this blade, and if you go for inaccurate and I can show mesh result, you can see there is no imprinting. Means you can't differentiate that if there is blade. Means previously here I have one blade, but in compatible you can easily differentiate that after adding blade also. So this compatible is this. Okay, I will just show this. Okay, incompatible, if you go for a results, we will verify, means we will go for the result afterwards. Now we will go for another one. So I will just copy this study, and instead of compatible accurate mesh, we'll go for a simplified. Okay. Okay. Now here, now I will change my condition incompatible to simplified and okay. Other things are same. So if you go for a run, in value you will see the changes, but in mesh or other things you can't see that changes directly. If I show here a mesh, the incompatible because of incompatibility, the elements on blade and as well as on part is not uh, s- simplified or engageable. So we will compare these three results of displacement because stress is the simplest. So don't go for a stress, go for a displacement. Okay. Now if you see here, whenever there is a compatible mesh, the results are more accurate. It's basically those considered all the touching faces with all node and elements. But in simplified mesh, if you go for incompatible simplified mesh, then this is another simplified mesh. We basically for source element means in our case blade is my source element. So at the bottom face of blade there are nodes. So we consider those nodes only, and on this planar circular face is called as a target face. On that we will consider the element is basically uh, whatever the nodes at the bottom of this blade we have that share some elements. So if this node have this element, then for calculation we are going to consider this element and this element. In between these two node we don't have any node, so it won't consider these bottom elements of target place, so it will create a patches. Because of that the calculation gets simplified, time also gets reduced, but your accuracy level is get reduced also. Means in this image you can show node base interval bond between an edge and a face. Only the element where node uniquely lies on their faces will participate in contact, and this leads to patch description on contact, which may lead to less accurate result. And in accurate bonding condition, if you see this image, then you will see the entire edge of a source, means whatever nodes source element have, that consider the element below that nodes, as well as whatever elements which means when means any node which don't have, means in between these two nodes these two elements are there but node is not there, but it will consider uh, those elements as well. So for calculation purpose, at the touching faces, how many elements are there, that whole going to be considered and simplified. Because of that, the calculation time is less uh, greater than simplified inbound image, but your result is more toward accuracy. Okay? So basically, if you if you want to take means if you want to consider the accurate result, then you definitely go for a compatible mesh. But sometimes due to complexity, this compatible mesh won't uh, means not able to create. At that time your meshing get failed, so you need at that time you need to choose incompatible mesh, and in that there are three options: automatic, one is a simplified, one is accurate. And here you can see accurate and simplified means if you don't want that automatic, you can directly select as per your requirement the accurate one and the simplified one. Means if you go for results with the preference, means accuracy with the preference, then greater accuracy will achieve in compatible mesh. Then second one is incompatible with accurate mesh, and last one is incompatible with a simplified mesh. And the third, if you see that chart, you have in properties. If you see this in the boundary option, there are three options. I have explained simplified and more accurate. While automatic, what it does, it automatically means when the automatic option is selected, the software will decide which is the most appropriate bonding type with respect to model and solution time, and it is suggested to leave this option as a default bonding type. Means you don't need to select more accurate result. If you need that accuracy, then you may go for more accurate instead of automatic. But by default, automatic is good other than simplified and more accurate because it automatically decide time and complexity. And so this is how basically compatible incompatible mesh is going to happen. And this option only comes in bounded contact condition. It won't came in no penetration or other allow penetration context, so kindly make a note of it. So this is all about today's session. I hope you will understand the compatible incompatible machine, and as per the condition is you are now able to apply it. So thanks for watching. Do like, comment, and subscribe to my YouTube channel. And in future, you will get in deep knowledge of Solidworks in coming videos. And after this tutorial series, I will also include the industrial oriented or whatever issues I have faced during the industrial project, that will also explain to you. So thank you guys.